Okay, here's another example about scale as well. If you notice over here on the left, I have a letter F, which I've drawn on the grids, and you see that it's 6 units tall and it legs off it at 3 units wide. If I want to make a scale copy of it, then my scale copy has to be like over here on the far right. So if we see my 6 units, it became 12 units. My 3 units became 6 units. Pretty much I multiplied this times 2. And if this was multiplied by 2, well, this had to be multiplied by 2. And so we see that how scale applies here. Now our red F is not to scale since only the height was doubled. Because only one thing was doubled, it's not to scale. And as such, also not proportional if we had a relationship there. Let's talk about the next one. Okay, let's look at these two polygons here. On the far left, you see a base of 12 units, a left side of 9 units, you see 6 units across the top, and pretty much in the grids are pretty much corresponding. If you look at the one in the top right here, over here, you're going to realize that it's 2/3 the size of our other one. 2/3 the size. Think of it, 9, or this 6 units right here. 2/3 of 6 is 4. 2/3 of 9 is 6. 2/3 of 12 is 8. There's a relationship there that's the same. And so this right here is a scaled copy of this. A scaled copy. So there's something you can kind of like think about here when we talk about scale. On the previous slide, we talked about doubling. Well, we can talk about also reducing something in size too in terms of scale. And so one of the things that you'll be doing today is doing something like the previous slide where you have your own letter, and then some where you have your own polygon. You don't have to get too complicated. If you have to use a square for just a simple rectangle, then do that. Just try the best you can and try and garner an understanding of scale and what it means. All right, out here.